switches ini they cannot see IP addresses because they live on layer 2, and in layer 2 there's no such thing as IP addresses. IP addresses only exist in layer 3. So the way the switches know where the packet should go, you need through something called physical addresses. If you go to the terminal, and then you do ipconfig /all ipconfig /all ipconfig /all. There you go. You can see that setiap interface ini dia ada physical addressnya. Physical address ini the same thing as a MAC address. Right, so switches itu mereka tahu where to send the frame based on the MAC address. Jadi inside of this frame, there's gonna be, if you Google what does a computer frame look like in networking, it's going to contain header sama trailer. Now, inside of this header sama trailer, it's going to contain ini, the sender's MAC address sama destination MAC address. Jadi nanti switch ini is going to read that part of the frame, and then it's going to send it to the corresponding interface, corresponding cable where the MAC address is located. So that's access control. Biasanya it also manages VLANs, tapi belum diajarin. Flow control, right? I should probably write this down. No. Jadi pertama physical layer 1 physical. Ini ada tadi converts digital data into physical signals. Example-nya ada cables, Wi-Fi, repeaters, or hubs. Right. Terus di layer 2 ada namanya data link layer. Data link layer. Di sini ada sublayer 1 itu MAC media access control, and then layer 2 sublayer 2 ada LLC, logical link control. I'm not using them, right? Di MAC tadi itu detects collisions. Did I spell that correctly? And then there's error control, and then there's access control, which I think anywhere to send the MAC address, VLANs. Right, sekarang logical link control. Kalau media link control itu tadi dia lebih bridges the data link layer with the physical layer kan. So it handles a lot of the physical stuff. For example, kayak tadi collision detection itu kan physical, right? If there's a physical signal that collisions with each other, the switch detects that, right? And then logical link control ini lebih ke logical side of things. So in this sublayer lives the, for example, ARP and then RARP, terus all the layer 2 protocols, right? And the function of LLCs ini ada tadi framing. Framing ini the process of tadi mana tadi, bro? Did I get disconnected? Okay. The process of encapsulating this packet, the green part, with the blue part. It encapsulates it into a frame. Itu namanya framing. And then ada lagi flow control. Flow control ini controls the flow biar it minimizes the collision. Jadi kalau misalnya there are contoh kalau half duplex itu kan harus giliran. Yang ngatur itu logical link layer. Logical link control, LLC layer. Terus flow control ini juga include bandwidth negotiation. So for example, if you have gini, if you have a router 1, terus ini a cable, and then router 2. Router 1 can handle 1 gigabyte bandwidth. Router 2 can handle 10 gigabyte bandwidth. Tapi sedangkan kabelnya sendiri, it can only handle 100 megabit bandwidth. So, dia negotiate bandwidthnya dulu. Ini yang paling kecil bandwidth yang mana? Kita pakai yang itu, right? So in this case, we're gonna use 100. Soalnya kalau kita send 1 gigabit per second, the cable's not gonna be able to handle it, right? Terus kalau misalnya the cable is capable of doing 10 gigabits, right? Dia negotiate bandwidthnya sama router 1 sama router 2 dulu, mana yang lebih kecil. Kalau misalnya router 1, router 2 ngirim 10 giga, router 1 nggak bisa accept 10 giganya, and then that's gonna result in significant packet losses. So that's flow control. Di sini ada tadi apa? Reduces collisions, and then also bandwidth is negotiation. Example-nya itu frame creation, terus ada juga multiplexing. Multiplexing itu the form yang kayak tadi half duplex, right? Atau full duplex. It sends multiple signals over the same cable. Itu multiplexing. Atau maybe kalau gini, there's this switch, there's this router, right? And then there's 5 PCs communicating at the same time, right? Berarti ini yang ngatur supaya this is not congested, so that this is not congested and nggak banyak collision. Itu juga data link, itu juga logical link layer, right? Because there's like 4 stuff going in at once. Nanti di link ini itu contains datanya dari PC1, PC2, PC3, PC4. So that's multiplexing. Multiplexing itu sending multiple signals or streams of information over a communication link in the same time. So multiple input goes to the same cable into the same output. Multiplexing. And then that's layer 2 done. Oh yeah, also switches. Switches. Frames, keywordnya. Right. So I'm gonna explain kenapa repeater sama hubs ini masuk ke physical layer, right? You might see dulu how to use hubs diagram. You might see that hubs ini mirip-mirip dengan switch. Mana? Bro, give me a hub. Host ini misalnya laptop, right? Ini connectionnya mungkin mirip-mirip dengan switch. And like, what's the difference? Bedanya kalau hub itu physical layer, artinya gini. Every signal that it gets, dia instantly langsung repeat that signal, right? Physical signal. For example, voltage. If it sees a voltage, it repeats it through all the different ports. So if there's 3 computers here, right? Host A sends something to the hub, and then the hub forwards this to every single port there is. Kesini sama kesini. So basically, every single packet atau frame that is sent, itu turns into a broadcast. And that's not good. Soalnya you're filling in a lot of cable's bandwidth. So you're gonna get a lot of traffic jams within a lot of those cables. Jadi it's also gonna slow down the performance of the network. Next, itu kenapa repeater sama hubs by to gini repeater hubs. What is a repeater hub? Because the function they perform, they just repeat the voltage. That's the keyword. Next itu layer 3. Someone hack me? The stream is full. Can someone what the fuck? Ada berapa orang?
More 16.
What
More
the
than 16.
fuck?
Yeah.
Can someone kayak screen share my screen? Telepon.
Ntar. Bisa kayak gini. Kalian sih bikin channel baru terus kita videoin. Buka kamera mungkin.
Enggak, just open the screen share here, terus share my screen. Oh, there we go. Thank you.
Bisa.
Ya.
Bisa gak?
Kalau misalnya any of you guys have a question atau wants to correct me on something, just cut me off, by the way. So only there's a couple of these concepts yang I'm not quite sure it's 100% correct as well. So next itu layer 3, network layer. Network layer ini keywordnya IP address and then routers gitu-gitu, right? So the point of layer 3 itu to handle where the data should be sent to, which is exactly the functions of routers kan. They route all the IP addresses. Cloudflare, what's the layer? Layer 3. Okay, that's not clear. The network layer, bruh. The network layer is responsible for facilitating data transfer between two different networks. And that's basically the network layer. Biasanya there's something called packets, right? Yang tadi I mentioned. In this picture, ini packets. No, let me drink. Ini biasa layer 4. Layer 4 splits the data into segments, and then packet layer 3 ini it splits this segment into multiple other packets, and then ditambahin header. For example, the IP address, destination IP address sama sender's IP address, source sama destination IP address. What are the functions of this? Right, packet encapsulation kayak tadi. Encapsulation. Oh god. Okay. Packet encapsulation. Terus ada routing or addressing, which is the function of routers. Path selections. Biasa there are namanya dynamic routing, right? So instead of putting physical static IPs manually and then determining the next hop by eyeballing it and like looking at the network structure, you can use pathfinding algorithms. For example, ada yang namanya RIP atau ada juga yang namanya OSPF, right? And it's going to automatically determine the best path for the network. So you don't have to manually determine the next hop. And then there's also sebelum packet encapsulation, segment fragmentation into packets. Itu layer 3. The key point is that ini two different networks. Oke, sekarang layer 4. Layer 4 ini di transport layer. The transport layer manages traffic between systems. It's responsible for end-to-end communication between the two devices. So, I'll start with the example. You might have heard of TCP sama UDP. TCP ini bukan TCP IP model ya. That's a different thing. TCP ini the protocol TCP, Transmission Control Protocol. Kalau UDP ini user data grab protocol. And the functions of these itu they are protocols that you often use to transmit data. Tapi kalau bedanya kalau TCP ini they prioritize accuracy. Kalau UDP it prioritizes the latency. So, for example, if I want to send an image to Discord, right? Maybe icekitten.com/100/100. If I want to send an image to discord.com through my friend's DM, itu I want full accuracy of this image. I don't want any part of this image being corrupted atau lost during the transmission, right? So what I want to use as a TCP layer, and that ensures that kalau aku kirim gambar ke temanku, my friend is not gonna see like a random black hole here, right? Because of the packet loss. So the TCP ini if it sees there's a packet yang atau if there's a segment yang nggak lengkap, it's going to tell siapapun yang ngirim, right? Hey, the packet you sent me isn't complete, so I need you to send another one. There's a really interesting visualization by Electropoo. TCP. How network nodes communicate. This is a pretty good short. It's pretty funny as well. Itu TCP. Kalau UDP ini, contohnya if you play multiplayer online games, right? For example, Valorant. Valorant itu it's okay kalau misalnya there are bits of data yang nggak apa namanya, yang nggak fully transmit. Okay, it's okay to have packet loss, right? Tapi yang penting latency. You don't want to be playing Valorant with like 30 millisecond latency. That's the point of UDP. Kalau UDP it prioritizes latency tapi boleh error. Kalau TCP nggak boleh error, tapi latensinya tinggi. Right. So back to the transport layer. It's responsible for end-to-end communication. Jadi between point A to point B, it ensures that the segments are transported properly. Sometimes di sini juga ada error checking. For example, kayak di TCP tadi kan ada error checking, right? Error checking itu biasanya only for TCPs and other protocols. Soalnya kalau UDP ini nggak ada error checkingnya. And then next, in terms of transporting data, there's also data segmentation tadi. So if you have a 50 megabyte data, it segments it into multiple namanya segments, which is what you see here. Segments. And then dia juga bisa flow congestion between the paths. So it tries to reduce it uses all sorts of algorithms to reduce the congestion dari path A to path B. Actually, you know what? You might be a bit confused soalnya bedanya data link layer sama transport layer can be a bit vague sometimes. Kalau misalnya data link layer, right? Itu dia lebih physical. So if there's a PC here and there's a PC here, and then there's a switch here, dia lebih handle congestionnya antara physical ini, antara apa ya? What do you say? Antara the same network. Itu kalau data link layer. Tapi kalau misalnya layer 4 itu lebih ke internet, right? So if you have maybe Indonesia di sini, right? This is a router and this is your computer. You need to access like multiple other routers, and maybe routernya it's a very complicated mesh so that you can access the Valorant server. And basically it just tries to find the most efficient algorithm, the most efficient path supaya it avoids congestion through different networks. And then next is multiplexing. multiplexingnya ini beda sama yang di sini ya. Kalau multiplexing yang di data link itu lebih ke allowing one cable to transmit multiple data. Tapi kalau multiplexing di transport layer, ini they use ports. So kayak tadi kalau di PPE itu kan you often see localhost titik 2 8000. 8000 ini the port that it uses, right? Jadi in general one IP address itu punya around 25,000 ports. So it's like you can I guess you can say that you can separate it into 25,000 different streams atau inputs outputs gitu. That's multiplexing. Ada TCP, UDP, ada ports. There's also flow congestion, path selection, and then layer 5. Layer 5 ini session layer. Now, starting dari layer 5 above, itu the TCP/IP model starts. The OSI model starts to get more vague. Since this is the session layer, I found that what it basically what lives in this session layer is basically everything that has a session that is also related to networking. So for example, TCP/IP ini ada namanya three-way handshake. Three-way handshake TCP. There's SYN, ACK, terus ACK, right? So this establishes a session. What exactly is a session? A session itu basically you're building a road from A to B so that you can send data between A to B, right? So in this case, you need the TCP three-way handshake process. It's basically establishing a connection atau a session dari client to the server, right? The client says to the server, hey, I want to establish a connection. The server says, okay, let me know if you still want to establish a session, right? So it acknowledges this synchronized request, and then it sends another synchronized request, and then the client says, yes, I still want to create a session. So it says acknowledge, right? So the moment that this three-way TCP handshake kelar, itu the session gets established, right? Terus another example of sessions itu if you're into web developing, you might have heard into webhooks atau I forgot apa namanya webhooks, WebSockets, atau maybe you've also heard of session tokens, right? I shouldn't dox myself. No. There's also session tokens. Session tokens itu, have you ever thought how Binus Maya knows that you're already logged in inside of your web browser? Kan whenever you log in, biasanya besoknya masih bisa ke login kan? You don't have to log in another second time, right? So that mekanismenya gini. Every time you log in, the Binus Maya server sends an instruction to your web browser to save something called a session cookie, right? And you can inspect this the application, right? You can expand the cookies di sini, right? And then you can check all of these, right? And nanti beberapa di situ there's gonna be something called a session cookie. It might not be very obvious, but biasanya pasti ada di situ, right? Atau kalau nggak ada di situ di local storage atau session storage. So, what that does is, since it saves it in your browser, right? Every time you open Binus Maya, you're gonna your web browser is gonna send that session to the server for Binus Maya, right? And the server is gonna validate that whether this session token is still valid or not. If it's still valid, it's gonna give the credentials. Jadi you don't have to log in again, right? Tapi if it's invalid, then it's gonna tell the website that, hey, no, this session token that you sent me is not valid, right? Maybe it's already expired, or maybe the server forced it to change. So you need to tell the user to log in again, so I can send you another session token. So that's session layer, basically anything that is related to sessions and networking. Gunanya session layer ini to establishes, maintains, and terminates sessions. Terminate sessions ini contohnya kayak tadi. Kalau misalnya setiap session cookie, setiap session token, itu biasanya ada expiry date-nya. Jadi kalau di Binus Maya kan setiap beberapa hari sekali kan disuruh login lagi, right? Nah itu soalnya session tokennya udah expired. So